Hi, this is me. Today we're going to talk about our solar system. We are not talking about astrology. That was a misprint in the program. I don't quite know how it got there, but I am going to be talking to you about astronomy. So that's great. Who's retired? Yeah! Isn't it good? And for the rest of you, too bad. We'll talk about some of the other points in the other lectures that are following. There's 3 more lectures that will follow this. Okay, so first of all, we're going to go and take a quick tour through the solar system. This particular graphic is a representation of how the solar system may have been created in one theory. We have other theories. I'll tell you the more scientific ones as we go. So we're going to start at the sun, and we are going to move out to the outer planets. You'll pass Mercury, Venus, Earth, Mars. We'll go through the asteroid belt where you won't see any. We get to Jupiter, Saturn, Uranus, Neptune. We'll end up at Pluto. Then we'll turn around and we'll dive back into the middle of the solar system, and you will see Ceres, the asteroid that was first discovered, the first asteroid that was discovered in the 1800s. And there will be a quiz at the end of this very short video. So I hope you're ready. Here we go. I chose the music as being very appropriate. I'm sure some of you will recognize it. Okay, how fast were we going? Qualitatively, how fast were we going? Come on, I don't hear anything. Give me a figure. 186,000 miles, that's the speed of light.
35,000 miles.
35,000 miles. How many? 100 billion light years. But okay, we were going faster than the speed of light. The amount of time it takes for the light to get from the sun to us is 8 minutes. We got to the outer edge of the solar system, back into the middle, in about 1.5 minutes. So we were going many times the speed of light. All right, solar system, what's in it? Planets. What else? Moons. What else? Asteroids. What else? Comets. What else?
Tanzanite.
What?
Tanzanite.
Tanzanite. Oh, I wasn't going to that level of granularity. Very good. That's what's there. Artificial objects was something I added the other day when someone mentioned the space station. So yes, there's lots of stuff in it. But there's one thing that's not there. We'll cover that in a minute, and that's dust. There's not very much dust in our solar system. There's a reason for that. What's more fascinating about Mercury is its strange revolution and rotation. It was once believed to be tidally locked. That is, the same face pointing to the sun all the time, and no rotation. So you can imagine on one side of the planet you were going to get absolutely toasted, and on the back side of the planet you were going to freeze to death because it never saw the sun. Not true. It actually rotates very slowly and in a very peculiar way. Well, this diagram shows how it happens. So if we start here, that little red line at the top shows you the position. As it rotates round, as it gets down to here, it's gone a half rotation. It gets round to here, it's done one full rotation. And when it gets back to the top, it has rotated 1.5 times in the time it's taken to revolve around the sun. This has some very strange features, as you'll see in just a minute. It is here where the dotted line is. It's extremely large. This impact must have been absolutely enormous because it actually affected the other side of the planet. So when the impact occurred over here, the pressure waves went around and through the planet, and on the other side of the planet you find jumbled terrain from the impact that happened on the other side of the world. So that must have been pretty horrendous when it occurred. Viking 1, 1976, NASA released this picture where you see this very clear face. Shortly after that, we get pictures like this. We've got pyramids identified here. We've got a city identified here. Here's the face. There's a wall. There's a circular crater. This must be an old city. No, afraid not. These are some more recent ones. This is the structure that was the face. This is 3.6 kilometers down there. An optical illusion. There's the face again to compare to this structure. This is in 1976. This is in 2001. Somebody did come up to me after one of these talks and said that he thought what had happened here was NASA had sent up hydrogen bombs to obliterate the face so that they could cover it up. I don't think so. I'll read this. President Obama stated this. By the mid-2030s, I believe we can send humans to orbit Mars and return them safely to Earth, and a landing on Mars will follow, and I expect to be around to see it. Well, actually, there's a project underway right now that is going to beat his timeline. We're going to talk about that very quickly. This is the Mars One project. This is a video that I pulled off their website, edited down somewhat to show you some images from what they're planning to do, and added an appropriate soundtrack. So this is one of their landing vehicles. This is going to be the site of an early colony. These are the living areas. Actually 40 of them will go to Mars, and as I said, it's a one-way trip. They are not coming back. This is what they're going to go in. This is the crew module. There'll be 4 cosmonauts in there, astronauts in there, whatever you want to call them. This is their lander. That's how they'll land. This is their living accommodation, although it's not quite what it's going to be looking like. These living areas are supposed to be buried under topsoil to reduce the radiation exposure that the people will be living under there. So I said I'd tell you why Pluto's been demoted. This is why Pluto's been demoted. This is a paraphrase of the rules of what a planet is. The only thing that distinguishes a dwarf planet from a planet is this statement here, really. What that means is a planet will clear its own orbit of any debris. As it goes around, if there's any dust, the gravitational force of the planet will suck it in to the planet. There will be nothing left in the planetary orbit. A dwarf planet is too small to do that, so there will be junk left in its orbit. And as I said, don't feel sorry for Pluto. There's quite a few dwarf planets in our system. Everything else now that's in the sun, all the asteroids, the meteors, and the comets that are part of our solar system are now called small solar system bodies. But don't feel bad, still calling them meteors and asteroids and comets. This is Pluto, as I said. But before I go on to that, I just want to talk about radiation levels. If you ever wanted to go out to Jupiter and go for a walk on some of the moons there, the radiation levels there are very hazardous. This is Io. In one day, you will get a lethal dose of radiation. It's not safe out there. Contrast that to Europa. There's 1 day's exposure. It's not particularly good either. Ganymede, you'll get a smaller amount. By contrast, that little line there is Earth for a 70-year exposure. So it's insignificant. And I've also given you the Mars mission for a 3-year mission there, which is a significant amount. Titan. I wanted to talk to you about Titan. It is the 6th moon of Saturn. The bulk of the mass of all the moons in that planetary system is all in Titan. So if you added up the weight of everything in there, of all the moons, this is Titan, and the rest of them are there. If you remember, there's 62 moons there, so all the weight is here. This is the surface of Titan. Looks a bit like Mars, actually. So what's unusual about Titan? Titan has an atmosphere. It's the only moon that's got an atmosphere. It has oceans. It's nothing like our atmosphere. But it is possible that there is life on this planet. As long as it's very different, it would have to have a completely different metabolic process. For example, it would have to inhale hydrogen instead of oxygen, and it would excrete methane instead of carbon dioxide. That's possible. It is cold, but there's heat down below from tidal heating, from gravitational heating, from the planet. So underneath the oceans, there could be some weird life. The other thing that's going to happen to Saturn's moon is in about 5 billion years from now, so don't hang around waiting to watch this, the sun is going to explode, the Earth will be incinerated, and it will get nice and warm on Titan. That stage of the sun's life, which I'll talk in more detail about in Death of Stars, is going to last enough time for life to develop on this moon, because the conditions are right. And that brings me to the end of a very quick tour through our solar system, and I'm bang on time. Any questions? On there.
What caused the decrease in gravity on Mars?
What decreased the gravity on Mars? What caused the decrease in gravity on Mars? Nothing. It didn't change. No, the gravity didn't change. The gravity is low, which is why the oceans escaped. No change. To change gravity, you have to change mass. There's a question there.
Why are they not coming back from Mars? Is it?
And why are they not coming back from Mars? Technology. They only have the technology to get them there. There'll be only enough fuel carried to get them there. It's a decision. And interestingly, this decision for a one-way trip has caused the Muslim community to issue a fatwa against this trip. So any devout Muslim is forbidden to go because the Muslims see this as suicide, and that is forbidden in their religion. Yes?
When they finally do die, what are they doing with the bodies?
I'm sorry, I didn't hear that.
What are they going to do with the bodies eventually when they do die?
What are they going to do with the bodies of the people on Mars when they die? I think they will bury them. And they're not coming home. Yeah.
How long will they?
Just a second, there was one there.
What's the life expectancy?
We don't know. I mean, when you think about what could happen up there, these are very brave people to do it. They're going into completely uncharted territory. I presume one of the first people that will go up, I hope that one of the first people that will go up will have medical training, and they'll carry some medical supplies, but there's going to be no emergency rooms, no intensive care. They'll have very limited supplies. These are real pioneers going off, very brave people. Who's funding it? The Mars One project. Who's funding it? It is a privately funded organization. They are funding it through sponsorship and crowdfunding. One of the ways they're doing it is you can name a crater on Mars. You can even buy a province or a state. And I believe the University of Colorado is one that has bought a state on Mars, a little square piece of property. What do they hope to achieve? Exploration. It's what we do. It's what humans do. There was a question here. Okay, thank you very much. Hope to see you at the other lectures tomorrow, this place, 3 o'clock.